Hello students, welcome back into my channel. I am Mr. Henrik. In this video, I would like to explain nature of a quadratic equation roots based on its discriminant value. As you know, that a quadratic equation ax squared plus bx plus c equals 0 has discriminant b squared minus 4ac. So now let's start with the first nature of discriminant. If discriminant equals 0, it means b squared minus 4ac equals 0. If discriminant equals 0, the quadratic equation has equal roots, which is real number. For example, if x squared plus 8x plus 16 equals 0, a equals 1, b equals 8, and c equals 16. So discriminant equals x squared minus 4 multiplied by 1 multiplied by 16. It's going to be 64 minus 64 equals 0. According to this calculation, we can state that this equation, this quadratic equation, has equal roots. Equal roots meaning x1 equal x2 and is the real number. Real number, it means x1 and x2 is real number. So we can determine x1 and x2 minus b plus minus d over 2a. And it is minus 8 plus minus square root 0 over 2 multiplied 1. Minus 8 plus minus 0 over 2. So x1 equals minus 8 plus 0 over 2 equals minus 4. And x2 equals minus 8 minus 0 over 2. It's minus 4. So look that x1 equals x2. How much? Negative 4. So these quadratic equations has equal roots, and the roots is negative 4. Second nature, if discriminant less than 0, it means b squared minus 4ac less than 0. If the result, if we calculate b squared minus 4ac, the result less than 0. If discriminant less than 0, it means we can state that the quadratic equation has unequal roots, which are the roots are imaginary numbers. For example, a quadratic equation to x squared plus 6x plus 8 equals 0. So a equals 2, b equals 6, and c equals 8. Let's calculate the discriminant. Discriminant 6 squared minus 4 multiply 2 multiply 8. 36 minus 64. It is minus 28, less than 0. So we can state that this quadratic equation has unequal roots which are imaginary numbers. So this quadratic equation. Prove. Let's refine. So if discriminant equals minus 28, it means x1 and x2 equals minus 6 plus minus square root minus 28 over 2 multiply 2. Okay, so it becomes minus 6 plus, we cannot simplify this, over 4. So x1 equals minus 6 plus square root minus 28 over 4. And x2 equals minus 6 minus square root um, square root minus 28 over 4. 20 minus 28, square root minus 28 is an imaginary number. The third nature is discriminant greater than 0, and the discriminant value is a perfect square number, right? If the nature like this, we can state that the quadratic equation has unequal roots, which are rational numbers. Rational numbers is a part of real numbers, as you know that real numbers consist of rational number and irrational numbers. Okay. For example, if x squared, a quadratic equation x squared plus 5x plus 4 equals 0, it means a equals 1, b equals 5, and c equals 4. So discriminant equals b squared minus 4ac. So discriminant equals 5 squared minus 4 multiply 1 multiply 4. 25 minus 16 equals 9. 9 is a perfect square number. Why? Because square root 9 is equal positive or negative 3. Okay, so we can state that these equations, these quadratic equations, has unequal roots, which are rational numbers. Proof. Okay, so x1 and x2 equals minus b plus minus square root discriminant over 2a. So x1 and x2 equals minus 5 plus minus square root 9 over 2 multiply 1. It is minus 5 plus minus 3 over 2. So x1 equals minus 2 over 2 minus 1, and x2 equals minus 5 minus 3 minus 8 over 2 minus 8. So minus 4, I mean minus 1 and minus 4. Look that x1 unequal with x2, different. X1 equals minus 1 and x2 equals minus 4. So this quadratic equations has unequal roots, and these unequal roots are rational number, -1 and -4. The last nature is fourth nature if discriminant greater than 0 and the values of discriminant are not a perfect square number. Right. So it means if the condition like this, if the nature of discriminant like this, we can state that the quadratic equations has unequal roots which are irrational numbers. As you know, just now I told you that real numbers consist of rational number and irrational numbers. Okay, okay, that's one. Rational and irrational numbers. Right, for example, if x squared, a quadratic equation x squared plus 6x plus 4 equals 0. It means a equals 1, b equals 6, and c equals 4. So discriminant b squared minus 4ac will be 6 squared minus 4 multiply 1 multiply 4. 36 minus 16 equals 20. Look, that 20 is not a perfect square number because why? Because square root 20, we can't find an integer number, but we can convert becomes square root 4, square root 5, becomes 2 square root 5. Okay, this number is an irrational number, okay, not rational number, irrational number. If 4 is rational number, 6 rational number, 1 rational number, but 2 square root 5 is an irrational number. If the condition like this, we can state that this quadratic equation has unequal roots, which are the roots the irrational numbers. Okay, this one. Proof. X1 and x2 equals minus 6 plus minus 2 square root 5 over 2 multiply 1. So it becomes minus 6 plus minus 2 square root 5 over 2. It's going to be divided by 2 minus 3 plus minus square root 5. 1. So x1 equals minus 3 plus square root 5 and x2 equals minus 3 minus square root 5. This number and this number is an irrational numbers. And look that x1 unequal with x2. Okay, students, thank you for joining with me in this lesson. If you have any questions, you may ask me through my email. Thank you. See you.